Hello and welcome back to lesson 7.4. It's all about confidence intervals and sample size for proportions. So when we're dealing with proportions, remember it's because we have qualitative data, data that you would have to tally and get a proportion. So we are going to get a sample proportion, that's p hat, where X is the number that satisfies the question that we're asking out of N in our sample size. So we learned in earlier lessons what a confidence interval is and how to find a confidence interval for quantitative data. And now we're going to do the same for qualitative data. So we need the margin of error. The margin of error is calculating our critical Z value. And notice with proportions and qualitative data, we're using a normal distribution. We're back to a normal distribution. And so we have the critical Z of alpha divided by 2, because it's a confidence interval. We have half of our alpha on one side and half of our alpha on the other. And then we have to multiply that by our standard error. And this is the formula that you'll be expected to show on your final test when you're doing any of these problems with confidence intervals so that I can see your work. The confidence interval, so whatever confidence you're looking at, is going to be found by taking your p hat and adding and subtracting this margin of error. So there is a decimal program that you can use to check your work, but we're going to be mainly focusing on just using our formula. There are links to that decimal program in our modules as well. So let's look at example 1, where I go through one for you. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected adult residents in this city are surveyed to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they own cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of this city who have cell phones. So X is going to be the number of people in the sample who have cell phones. X is binomial, where 500 is our sample size and our P hat is 421 out of 500. So our P hat is 0.842 here, our sample proportion. And then that means Q hat is 1 minus P hat. So there's Q hat. And since our confidence level is 0.95, our alpha is 1 minus our confidence level. So alpha is 0.05 and alpha divided by 2 is 0.025. So we need to find our critical Z value of 0.025 using our table or Desmos. It's 1.96. And the table is in the back of your course pack. So remember, at the bottom of your new table is the Z values. So at 0.025, up here at 0.025, our Z value is 1.96. Okay. So the formula. So our margin of error is our critical Z value, 1.96 times the standard error, which is the square root of P hat times Q hat divided by N. So my margin of error is 0.032. And so my lower boundary of the confidence interval is my P hat subtracting my margin of error, 0.81, and my P hat adding my margin of error, 0.874. So here's my lower and upper boundaries of my confidence interval right here. And we would interpret this by saying, we estimate with 95% confidence that between 81% and 87.4% of all adult residents of the city have cell phones. So let's try one on our own. He says, suppose 250 randomly selected people are surveyed to determine if they own a tablet. Of the 250 people surveyed, 98 reported owning a tablet. So define the random variables X and P hat. So X is number of people who own a tablet, and P hat is the proportion of the sample who own a tablet. And X is also of the sample. So it's the number of people in the sample who own a tablet. Which distribution are we going to use? We're going to use, it is a binomial distribution, but we're using the normal distribution. So we have a critical Z value. It's qualitative data. And so to calculate the P hat, we have X divided by N. And we said that that is 98 divided by 250. So that comes out to be 0.392. And because we're dealing with a 95% confidence interval, the confidence level is 0.95. So alpha is 1 minus 0.95 or 0.05. And of course, we're using alpha divided by 2. So that is 0.025 again. So once again, Z of 0.025 has before it's 1.96. So this is what you would be showing for the work that you're doing on your Alex test, as well as your chapter 7. So we're predicting about the population where 95% of the data lies, 0.95, and then we have 0.025 out here and 0.025 out here. And so our margin of error is equal to 1.96 times the square root of 0.392 and 1 minus 0.392 divided by the N, which is 250. And when you put that into decimals, you get 0.0605 is my margin of error, which I'm doing right here. And then to state the confidence interval, we're going to take P hat plus or minus your margin of error. So that is 0.392 plus and minus 0.0605. And so my lower boundary is 0.3315 and 0.4525. And then we want to explain what this means. So we are 95% confident that the true proportion of people who own a tablet is between, I'm going to write it as a percent, 33.15% and 45.25%. 5. Okay. And you try one on your own. So I suggest you pause and just make sure that you can do this on your own, try it, and then come back and we'll do it together. Okay. So defining, it says for a class project, a political science student at a large university wants to estimate the percent of students who are registered voters. He surveys 500 students and finds that 300 are registered. So we're going to define X as number of sample of students who are registered voters. And P hat is proportion of sample who are registered voters. We should be using the normal distribution, the Z curve, because it's qualitative data. Just reminding ourselves. And to calculate P hat, we're going to take X divided by N. So that's 300 out of the 500, or 60% are registered to vote, which is great. Voting is not a privilege or a right, it's a duty as being a citizen of the country. So compute a 90% confidence interval for the true percent of students who are registered voters and interpret the confidence interval. So our confidence level is 0.90. So alpha is 1 minus that. So it's 0.10. We need alpha divided by 2, which will be 0.5, 0.05. So in our table, Z of 0.05 is 1.645. And so our graph here shows our 90% confidence in the middle. And then we have 0.05 on either side here. And our calculation of our margin of error is 1.645, the Z of alpha divided by 2 times the square root of P hat times Q hat divided by N. So in our case, the P hat is 0.6. Q hat is just 1 minus 0.6, all divided by N, which is 500. And that comes out to be 0.036. So our interval is going to be P hat plus or minus our margin of error. So that will be 0.6 plus or minus 0.036. When we do that, we get 0.564 and 0.636. And then to improve it, if we came up with the right interpretation, we are 90% confident that the true proportion of students registered to vote is between 56.4% and 63.6%. Fabulous. The next little bit is all about sample size. So we are dealing with proportions. We're going to calculate sample size. And for proportions, there's two formulas. So if researchers desire a specific margin of error, then they can use the error-bound formula to calculate the required sample size. The error-bound formula for a population proportion is this. So we have p hat and q hat. And this is if you have a prior estimate. So if you know something about your group of subjects that you're trying to predict the confidence interval for, like a prior estimate that you did or a prior sample or survey, then you have a p hat to work with. Then you're going to use this one, p hat and q hat. And then you're going to take your critical value, your critical z value of alpha divided by 2, divide by that margin of error that you are desiring, and you're going to square this ratio, remembering to always round up for your sample size. But if this is a new sample that you're gathering data from and you've never asked this question before, then we are going to use just 0.5 times 0.5. Because that is the largest it could ever be. Because if p hat was 0.6 and q hat was 0.4, it's going to be smaller. It would be 0.24. So 0.25 is the biggest this would ever be. So if you have no prior information, you're going to just use this formula, 0.25. And then your z of alpha divided by 2, that should say, divided by your margin of error, and that proportion or ratio squared. So the only difference is up here you would have an estimate of p hat and q hat, and down here you're just going to use 0.25. So let's go to example 4 and look at one here. So suppose a mobile phone company wants to determine the current percentage of customers age 50 plus who use text messaging on their cell phones. How many customers age 50 plus should the company survey in order to be 90% confident that the estimated sample proportion is within 3 percentage points? We're going to need that 3 percentage points of the true population proportion of customers who use text messaging on their cell phones. So from this, we know that our margin of error is 0.03 because it's 3 percentage points. And then they wanted to be 90% confident. So our confidence level is 0.9. So alpha is 1 minus 0.9 or 0.10. And then we have to divide by 2. So it's z of alpha divided by 2, which is 1.645. So to calculate the sample size, we do not have any prior information, so we're going to use 0.5 times 0.5, which is the 0.25. And then our z, our critical z squared divided by our margin of error squared. And then we always round up. So we got 751.7, and we're going to round that up to 752 in our sample. Let's try example on our own. It says, suppose an internet marketing company wants to determine the current percentage of customers who click on ads on their smartphones. I am guilty of that. How many customers should the company survey in order to be 90% confident that the estimated proportion is within 5 percentage points of the true population proportion who click on ads on their smartphones? So again, we want to be 90% confident. So our confidence level is 0.9. Alpha is 1 minus 0.9 or 0.10. Alpha divided by 2 is 0.05. So our critical value is 1.645. So our sample size, we don't have any prior estimates to use, so we're going to use 0.25 times the 1.645 divided by, we want it to be within 5 percentage points. So we're using 0.05, and then we're going to square that. And this comes out to be 270.6. And we always round up for sample size. So we're going to need to sample 271 people to make sure that we are getting the true confidence that we want. So that's the last of confidence intervals with proportions and sample size. Your formulas are here on this page, the last page of the lesson. Don't forget they're also in the back of the book, along with the formulas are in the back of the course pack, along with your T table and Z tables and some things that you're going to need. So just wanted to make sure you have that. Catch me back for another lesson.